All right, this is a review of the chapter 3 sum. And I'm just going to work through some of the problems that gave extra difficulty. Number 1 is to solve the system by graphing. So looking at this first equation, this is a linear equation, it's in standard form. So I would find my intercepts, and I would find my x-intercept to be 2, and my y-intercept to be -3. And then I would draw this line, and we continue with this slope going up 3 and over 2, up 3 and over 2, and I could draw this line. And the second line here would have an x-intercept of -6 and a y-intercept of 3, and then we're going over 6 and up 3.
Will junior high have shot clock then too?
And then we're going over 6 up 3, which is this line. And my graph is not real good, so we would kind of estimate where we believe they cross at. And on a better graph, you're going to see that it crosses at the point 6, 6. And then I would just check and make sure that this does work for both of these equations, which it does. All right, this is number 4, the 3 equations, 3 unknowns. So the first thing we would do is try to eliminate one of these variables. And I'm going to try to eliminate y here by multiplying this by 2. Make sure you multiply the entire equation through, and then by adding these, we eliminate the y, and we get this equation with 2 variables. Now, we do need to eliminate that variable again, and what I'm going to do is multiply this middle equation by a +3, eliminating that with the last equation. And then adding these two, I'd have -7x minus 12z is equal to a -77. So now I have turned this 3 variable into 2 equations and 2 variables. And now I would solve this by elimination. I could multiply this top by -2. The z's would eliminate. I'd have 3x is equal to a -3, so x would be -1. I would plug this back into one of these equations. This is going to give me 5 minus 6z is a -37. If I subtract that 5, I get z to be a +7. Then, plugging into one of the original equations, I'm going to plug it in right here. Since y is by itself already, -4 times -1 will be +4, plus the y, minus 35 is a -36. Combine like terms, and we get y to be -5. So listing these in alphabetical order, this would be our ordered triple. Number 6, you have to look at your test on this one. It says at a park there are 38 people playing tennis, some doubles, some singles. 13 matches in progress. A doubles match requires 4 players. Singles match requires 2. Write and solve a system of equations that will find the number of singles and doubles matches, which tells us our variables are single matches and doubles. And then looking at the problem, reading it more carefully, there's 38 people playing. In a doubles match, there are 4 players. In a singles match, there are 2. So that equals 38. That's dealing with players. And then it also says there are 13 matches. And then we have our system of equations. I would solve this by multiplying the second one by a -2. I get 2d to be 12, so d would be 6. And then plugging back in would give me s to be 7. Number 7, again, you'll need to read this more carefully on your own here. We're talking about roller coasters, bumper cars, water slides. In reading the problem, it talks about the wait time. It talks about that it's 60 minutes for a roller coaster ride. It is 20 for a bumper car. It's 15 for a water slide. And they spent a total of 380 minutes waiting. Said he rode 10 total rides. So all of these together should equal 10. And then it says that he rode the roller coasters the most, the same as the bumper cars, water slides together. I'm just putting this over to the side here because I'm going to rewrite this in the form of the other ones by subtracting b and w from both sides. And now I have a more traditional 3-equation problem. I'm going to eliminate b here, or w, so I'm going to add these two equations together. And that's going to give me 2r. The b's would eliminate and the w's, so 2r would be 10. Eliminating b again, I can multiply this last equation by 20. So I have 20r minus 20b minus 20w is 0. And then adding these two together, I'd have 80r minus 5w is 380. So this is my system of 2 equations. So from this equation, I already know that r is 5. I would plug in, so I'd have 400 minus 5w is 380. I could subtract the 400 to get w to be 4. And since there are 10 total rides, I'd have 5 roller coasters, 4 water slides, and 1 bumper car. Lots of different ways to do it. I like to just get all 3 equations in that same format. Number 8, if you read through this again, the big thing at the end, it says how many shoes of each kind. So we're going to let x be outdoor shoes, y be indoor shoes. Whatever they're asking for, let those be your variables. And then it says to maximize profit. So I want to have a profit equation. And they tell me that each outdoor shoe is 20, each indoor shoe is 15. And then I would write these inequalities. So it's a 2-step process. It says that in step 1, each outdoor shoe requires 2 hours. And in step 1, an indoor shoe requires 1 hour. And step 1 has 40 hours available. This would have to be less than or equal to 40. And then in the second step, an outdoor shoe has X. An indoor shoe has 3 hours, and there are 60 available for that step. And then we have our common ones because they can't be negative. So I have a vertical line through 0, horizontal line through 0. This particular inequality would have an x-intercept of 20 and a y-intercept of 40. I'd shade below that. And then I have an x-intercept of 60 and a y-intercept of 20 for the other one. And I would shade below. So this is my feasible region. Important points are my corner points, which you can see are 0, 0, 0, 20, 20, 0. This one's not so obvious. So I would need to solve this system. And if I multiply that second equation by a -2,
Say with,
so multiplying this middle equation by a -2, and then adding these, I get a -3y is equal to a -20. Oh, sorry. Got an issue here. This should have been a -120. And then I would have -5y is equal to a -80. And dividing by -5 will give me y to be 16. Plugging 16 in, I'd have 2x plus 16 is 40. I subtract 16, I'm going to get x to be 12. So this point is the point 12, 16. Then we're going to plug each of these points into this profit equation, get a profit for each of these. Just bear with me 1 second here. And this would be 480, which you can see that is the best possible situation that would maximize our profit, making 12 outdoor and 16 indoor.